All right, today we're going to dive deep into Unsloth. It's this fantastic tool that promises to take you from a basic AI model to a completely custom, high-speed version that you can run right on your own machine. So let's break down exactly how you can do it, step by step. You know the feeling, right? If you've ever tried to fine-tune a large language model, you've probably hit this wall. You get all your data ready, you set up your training job, you hit go, and bam, GPU out of memory. It's a super common and, let's be honest, incredibly frustrating roadblock for any developer. Well, this is exactly where Unsloth steps in. It's an open source framework built specifically to solve this problem, and the numbers are kind of staggering. We're talking about training models up to 30 times faster while using 90% less of your precious video RAM. And the best part? It does all this without hurting the model's accuracy. So how on earth does it pull off these incredible performance boosts? Well, it's not magic, it's just really, really clever engineering. Unsloth basically rewrites the most demanding math operations inside the model. It uses custom, handwritten code that talks directly to the GPU, fusing a bunch of stacks into one and just massively cutting down on that memory overhead. To make sure this is all crystal clear, we're going to follow this simple checklist. We'll start with getting your environment set up, walk through the actual training and deployment, and then we'll even cover a few common troubleshooting tips. By the end, you'll have the whole workflow down. Okay, first things first. Before we can even think about training, we've got to do a quick pre-flight check. Let's make sure our hardware and software are ready for takeoff. So yeah, this list covers the essentials. You'll need a reasonably modern NVIDIA GPU, the right version of Python, and your OS of choice. But here's the best part. Unsloth automatically handles all the tricky dependencies for you. You know, things like Xformers and bits and bytes. It's a huge headache saver. And getting started? It's surprisingly simple. For Linux, or if you're using the Windows subsystem for Linux, it's literally just a single command you paste into your terminal. There's an equivalent for PowerShell on Windows too. No complicated setup, you just run the script, and you're good to go. Now, let's talk about data prep, which is often the most painful part of the whole process. Unsloth Studio has this feature called Data Recipes that makes it so much easier. You can just upload your documents, PDFs, CSVs, whatever you have, and use this cool visual workflow to automatically turn all that messy, unstructured data into a perfectly formatted dataset. I mean, this alone can save you hours and hours of manual grunt work. Okay, with our environment set and our data prepped, it is time for the main event, actually training the model. And you've got two great options here. If you want a no-code experience, there's Unsloth Studio. It's a full web interface that lets you manage everything. But if you're like me and you love to be in the code, Unsloth Core gives you that deep programmatic control right inside a Jupyter or Colab notebook. Now, if you do go the code route, this is where the real magic happens. This one command, fast language model from pre-trained, does all the heavy lifting. It automatically grabs your model, applies super efficient 4-bit quantization, and injects all of Unsloth's performance-boosting tricks without you having to configure a thing. It's brilliant. As your model is training, you need to keep an eye on one key number, the training loss. It basically tells you how well the model is learning. You want to see it drop steadily into a nice range, somewhere between 0.5 and 1.0. Now, if it goes all the way to 0, that's a red flag. It probably means your model is just memorizing the data instead of actually learning, which is a classic case of overfitting. Look, a trained model is pretty useless if it's just sitting on your hard drive, right? You need to actually run it. So the next step is to package it up into GGUF, which is this universal format that lets you deploy it almost anywhere. And Unsloth makes this just ridiculously easy. Seriously, forget about complex conversion scripts. After training, you just call one single function, save_pretrained_GGUF. You give your model a name, pick how you want to quantize it, and that's it. Your model is packed up and ready for local deployment. And you've got plenty of options to choose from. You can pick the perfect balance of model size, speed, and quality for what you need. For most of us, Q4KM is going to be the sweet spot. It's a fantastic, well-balanced starting point. Now here's a pro tip for a super common snag you might hit. Sometimes that final step of saving the model can use a ton of VRAM. And yep, you guessed it, another out-of-memory error. But don't worry, if this happens to you, you are not alone, and there's a very simple fix. Unsloth gives you this incredibly handy parameter called maximum_memory usage. You can just dial it back to something like 0.5, which tells the process to only use about half of your peak GPU memory during the save. This ensures a nice, smooth export, even if you're working with limited VRAM. Of course, for those of you who really want to get your hands dirty and have total control, the manual path is always there. You can save the model parts yourself, compile the Llama CPP engine from source, and run the conversion script manually. It gives you maximum flexibility if you need it. Okay, this is the moment of truth. We have built our custom model, we've exported it. Now it's time to load it up in a tool like Llama or LM Studio and see if this thing actually works. So you load your new GGUF file, you ask it a question, and it spits out complete gibberish. Or maybe it just starts repeating the same word over and over and over again. If this happens, do not panic. This is literally the single most common issue people face, and the fix is usually very, very straightforward. The problem is almost always a chat template mismatch. See, a language model only knows how to have a conversation based on the exact format it was trained on. Think of it like a script for a play. If you change the script, the actor gets confused. If your inference tool uses a different format, the model gets confused and, well, the output is terrible. So, here is your simple go-to checklist that's going to fix this 99% of the time. First, make absolutely sure your chat template matches the one you trained with. Second, check your special tokens, like the end of sequence token. If you're ever in doubt, just open one of Unsloth's example notebooks. They show you exactly how the template should look. All right, let's just take a step back and appreciate what this entire workflow really empowers you to do. You now have a clear, fast, and efficient path to go from just a pile of documents to a fully customized AI model that you can run locally. You know, this whole process used to take weeks, sometimes months, and required a ton of expensive high-end hardware. With a workflow this powerful and this accessible, that barrier between your idea and a real working custom AI solution has never been lower. So the only question left is, what problem are you going to solve first?